Okay, let's dive right into this explainer. If you're building AI agents, you've definitely felt the friction of getting them to actually talk to your external systems reliably. It's tough, right? Well, today we are cutting through the noise and clearing up a massive misconception. We're going to reframe exactly how the Model Context Protocol, or MCP, relates to your existing APIs. Spoilers, it's not here to replace them. It's actually the ultimate conversational adapter.
Here's our roadmap for today. We'll kick things off with that core paradigm shift of adapters versus competitors. Then we'll break down the why and when, look at the engineering how-to, tackle those missing primitives, and wrap it all up with an architect's checklist.
All right, section 1, adapters, not competitors. Let's just establish a foundational truth right out of the gate. MCPs and APIs, they are absolutely not competing in some zero-sum game.
It really boils down to this contrast. Your traditional APIs, they're your foundational engine. They're stateless, built for discrete web requests, and require design time integration. But when you layer MCP on top, it acts as this brilliant, stateful, conversational adapter. It handles runtime tool discovery and persistent sessions. So you build the hard logic with your APIs, and you use MCP to teach your AI how to actually talk to that logic. I love this way of looking at it. Think of MCP as literally the USB-C for AI. It's a standardized layer that seamlessly routes an agent's natural language requests right down to your cleanly built microservices. And the beauty here is that instead of building a totally custom REST adapter for Claude, and then another one for ChatGPT, and another for Cursor, you just build one MCP server. The model discovers the tools, figures out the parameters, and interacts autonomously. It's a massive time saver.
Moving on to section 2, the why and when. Now this is where things get really interesting, because we need to dissect exactly when to use this adapter versus just sticking with a direct API connection.
Let's break it down. If you're just firing off a simple, discrete call, like filling out a basic Jira ticket with predefined fields, honestly, an API or an MCP tool is going to feel pretty much identical. But MCP completely takes over when things get complex. Say your agent needs to write out several subtasks that all share the exact same parameters or formatting. That requires persistent statefulness, which MCP nails. Or what about negotiating capabilities? Like deciding dynamically if a fast tool should run synchronously or if a huge data pool needs to run asynchronously. If you tried to build that with pure APIs, you'd end up with this insanely brittle tree of conditionals. With MCP, the client and server negotiate all of that seamlessly right up front.
And then there's bilateral communication. Have you ever wished your server could just tap your AI on the shoulder? Because MCP uses WebSockets, it creates a persistent, full duplex connection. This two-way street is an absolute game changer. Imagine a research agent doing its thing, and it just receives unrequested updates from the server as new info drops. Or if there's an error, the server can actually preload context on previously tried and failed solutions right into the agent's workspace. The agent doesn't even have to ask. You literally cannot do that with a standard one-way HTTP request. All right, section 3, how to build MCPs. The big question here is how we engineer these tools so they're hyper-efficient and agent-friendly. First rule, we do not throw away what we already know. You absolutely must borrow standard API best practices and bake them straight into your MCP wrappers. Remember, MCP is just the adapter. The core operations still need that classic API discipline. You have to enforce Atomicity and Idempotency, so if an agent retries a failed action, it doesn't, accidentally double charge a client. You still need pagination, and you definitely have to maintain least privilege and token isolation to keep things secure.
Now, this brings us to a super important concept: coarse-grained versus granular tools. Look, if you hand an agent 50 granular tools for every single API endpoint, you are going to burn through thousands of tokens just explaining what they do. Your finance team will hate you, and the LLM will probably just get confused and hallucinate anyway. The fix? Cluster those simple analog API calls into coarse user intents. Give the agent one single wrapper tool called issue_management that creates a ticket, assigns it, and tags it all in one go. You drastically reduce LLM interactions, token consumption, and latency.
And to keep that context window perfectly optimized, don't just dump every tool you own onto the model. Leverage semantic search at the gateway. This way, your system dynamically routes and presents only the specific tools that actually fit the current workflow. You're giving the LLM exactly what it needs, exactly when it needs it.
I really want you to burn this golden metric into your memory. Task accuracy divided by the product of time and cost. This is hands down the absolute best way to evaluate if your MCP wrapper is actually outperforming a direct REST API call.
If you build those coarse-grained tools correctly, your accuracy shoots up and your time and token costs plummet.
Okay, Section 4, Solving the Missing Primitives. We gotta be honest here and address the caveats. MCP is incredible, but for true enterprise-scale production, it does currently lack some native primitives.
To bridge those gaps, industry experts are borrowing mature API design patterns. For instance, MCP has a gap in authentication, specifically identity propagation. To fix that, we use CABP, or the Context-Aware Broker Protocol, to securely pass user identity down to the tool. For managing tricky timeouts across long chains of tools, there's 8TBA, Adaptive Timeout Budget Allocation. And my personal favorite, for handling errors without the agent totally freaking out, we use SURF, the Structured Error Recovery Framework.
SURF is super fascinating. It leans on the error taxonomy proposed by Srinivasan in 2026. Think about it. If an agent gets a generic error, it's just going to guess a fix or get stuck in an endless loop. But SURF gives it a deterministic cheat sheet. If the agent gets an invalid input code, it knows to reformulate. Resource not found, it verifies parameters. Resource exhausted means switch resources or escalate. Permission denied, boom, escalate to the human immediately. Upstream failure triggers a retry with backoff, and internal error means absolutely do not retry. Injecting this structured metadata moves your agents away from wildly hallucinating fixes and towards systematic, reliable self-correction.
And finally, Section 5, the Architect Checklist. Let's pull all these threads together into an actionable game plan.
Here is your checklist. Number 1, please don't reinvent the wheel. Keep your existing API best practices as your absolute bedrock. Number 2, view MCP purely as the robust conversational adapter sitting on top of those APIs. Number 3, consolidate. Cluster those simple API calls into coarse-grained tools mapped to user intents to save tokens. And number 4, implement patterns like CABP and SURF to plug any current protocol gaps.
MCP really is the bridge that lets your LLMs confidently and efficiently talk to your digital infrastructure. So looking at your own systems today, the ultimate question I want to leave you with is this: which of your well-oiled APIs is primed and ready to be wrapped as an adapter for the agentic future? Think about it. Thanks for hanging out with me for this explainer, and I'll catch you on the next one.